They didn't have a week. They had a product conference nobody announced.
Way they really did.
Welcome to a bonus deep dive of AI, frankly. If you're, building, operating, or frankly just trying to survive the current wave of enterprise tech, you're definitely in the right place.
Absolutely.
Our mission for this deep dive is highly specific. We are documenting everything Anthropic shipped in March 2026.
And a lot.
A massive amount. We're sorting it by who it actually affects on the ground. So everyday web users, code builders, and enterprise operators.
Right.
And we're doing this because of one undeniable reality that seems to just, it completely escapes most corporate leadership.
Oh, completely.
Most of this technology will be actively running inside your companies, deeply integrated into your proprietary workflows before your IT department ever approves it.
Or even issues a memo acknowledging it exists, honestly.
Exactly. So we've got the change logs, the documentation, the community repository data. Okay, let's unpack this.
Well, looking at the change logs in isolation is it's a mistake. If you just read the individual release notes Anthropic pushed out this month, it sounds like, a series of minor quality of life updates.
Like just UI tweak.
Yeah, tweak to a context window here, a new integration there. But when you map the dependencies between these features,
The broader picture.
yeah, you realize the entire architecture of how we interact with these systems just shifted fundamentally.
We're totally abandoning the single-turn query paradigm.
Right. We are moving into an era of persistent, scheduled, and highly autonomous operations. Operations that run completely beyond the immediate supervision of the user.
Okay, let's ground that, starting with the web users. The concept of persistent memory is now live for everyone.
Which is wild.
And that includes the free tiers. Claude now retains your name, your communication preferences, and your ongoing project context across entirely different sessions.
Right, from one day to the next.
Yeah, you no longer have to, reintroduce yourself or paste in the same dense background paragraph every single time you open a new chat window. It just knows.
And this shift, moving from a stateless architecture to a stateful one, it changes the baseline expectation of the user.
Mechanically, how is it doing that?
Technically, it operates through a mechanism of last modified timestamps and hidden system memory files.
Okay.
So before the model even generates the first token of a response to your new prompt, it's querying this localized memory file.
So it's reading up on you before it speaks.
Exactly. It's injecting your historical context into the system prompt invisibly. It grounds the model in your specific ongoing reality without you having to manually manage that payload.
I understand the convenience, but, and I got to bring this up, the transparency controls they highlight, like the ability to view, edit, or wipe those memories clean,
Yeah.
that leaves a massive glaring governance issue.
Oh, it's a nightmare.
Right. Let's say I'm a senior engineer. I use my account every day for a year to debug proprietary code, summarize internal deployment strategies, map out legacy server architecture, the highly sensitive stuff.
Yeah, the crown jewels.
Who actually owns that accumulated context?
That is the core governance nightmare we are facing this quarter. The memory feature is intrinsically tied to the user account identity.
Not the company.
Right, not necessarily the corporate tenant, depending entirely on how your organization has provisioned the licensing.
Okay, so if an employee spends 6 months inadvertently training this highly tuned context profile about company vulnerabilities.
And the deployment architecture, yeah.
And then they just resign.
That memory profile leaves with them. It resides in their account architecture.
Wow.
Or look at the inverse. If they decide to wipe that memory file before they hand over their laptop,
the company loses all of it.
yes, the corporate asset of that incredibly efficient workflow is permanently destroyed.
Wait, are you saying we're allowing employees to essentially build a bespoke, highly specialized assistant using our proprietary data, and we have absolutely no administrative mechanism to retain its brain when the employee walks out the door to a competitor?
I am saying the current administration panels do not offer granular tenant-level retention policies for localized user memory files.
That's absurd.
We are essentially relying on the honor system for data that has been implicitly rather than explicitly fed into the model's persistent state.
But, and this is where it gets crazy, this persistent memory becomes exponentially more dangerous when you realize how much data the model can actually hold at once.
Oh, the context window.
Yeah, they didn't just give Claude a memory, they gave it a massive immediate working brain. Sonnet 4.6 just launched in beta with a 1 million token context window.
Right. And to put the raw scale of that into perspective, 1 million tokens translates to roughly 750,000 words.
Which is just a staggering amount of text.
It really is. In
Yeah.
a single prompt, without any external database architecture, you can drop an entire year's worth of financial reports,
Wow.
or dozens of meeting transcripts, or an entire medium-sized application code base. It processes all of it simultaneously.
See, this makes me question the entire industry's current obsession with RA, retrieval augmented generation.
Yeah, absolutely.
We've spent the last 2 years watching enterprises spend millions building these complex vector databases just so their AI can search for documents.
And now it might be entirely unnecessary.
Right. A 1 million token context window essentially renders RAG obsolete for a huge swath of enterprise use cases.
It really does.
Think about the mechanics of RAG. It's like asking an assistant to go down to a dark basement, look at a massive wall of index cards, and fetch a specific file.
Right. And they might grab the wrong one.
Exactly. They might grab the wrong file, or worse, they miss the crucial connection between a document in drawer A and a related footnote in drawer Z.
Because they're only looking at isolated pieces.
Yeah. But a 1 million token context window is like having an assistant who has already memorized the entire filing cabinet word for word and can synthesize across all of it instantly.
The limitations of RAG are fundamentally architectural. RAG relies on semantic search, which requires breaking large documents into smaller chunks.
Right, to assign them vector embeddings.
Exactly. So if a user asks a complex question that requires connecting a passing reference in a January strategy document to a minor footnote in a December technical spec, RG almost always fails.
Because it just doesn't see the link.
Why? Because neither of those individual chunks scores high enough on cosine similarity on its own to be retrieved from the database and fed to the model.
That makes total sense.
But with a 1 million token window, the transformer's attention mechanism processes every single word in parallel.
It calculates the relational weight directly.
Yes, it calculates the relationship between the January reference and the December footnote directly. It finds the nuanced connections that the crude process of document chunking actively destroys.
I gotta push back on the practicality of that, though. What about the compute cost?
It's definitely a factor.
And the latency. You can't just shove 750,000 words into a prompt every single time you want to ask a question without the system taking 5 minutes to respond and costing a fortune in API calls.
Well, the latency is exactly why this is currently in beta. And it's primarily targeted at asynchronous analytical tasks rather than real-time chat. You are not using a 1 million token window to ask a quick formatting question.
Right, you'd use a smaller model for that.
Exactly. You use the massive window to perform deep structural analysis on a code base over the course of several minutes.
Okay, that's fair.
But the trajectory is clear. As inference compute gets cheaper and caching mechanisms improve, the brute force approach of massive context windows will inevitably replace the fragile plumbing of vector databases for all but the largest enterprise data lakes.
But raw text output, no matter how perfectly synthesized, isn't how executives actually make decisions in a boardroom.
No, they want visuals.
Exactly. Claude isn't just reading that massive data set anymore, it's now visualizing it. Claude can now generate custom charts and diagrams directly inline in its chat responses.
No separate artifacts.
Right. No exporting CSVs to external tools.
Yeah.
It's just right there in the chat.
What's fascinating here is the psychology of visual authority.
Oh, definitely.
There is a well-documented cognitive bias in corporate environments where human beings are significantly less likely to question the underlying methodology of information if it is presented in a clean, professional-looking graphical format.
We just trust a good bar chart.
We really do. Historically, when you separate data processing from data visualization, you introduce a natural, necessary friction.
Someone has to actually make the chart.
Right. A human analyst has to take the raw data, put it into Excel or Tableau, select the axes, consider the scale, and actively verify the trend line.
And that friction acts as an accidental quality assurance step.
Yes.
The risk for enterprise users now is that a slick, instantly generated chart completely bypasses our natural skepticism.
He looks too good to be wrong.
Yeah. If Claude hallucinates a data point or misinterprets a correlation in a dense paragraph of text, a domain expert reading that text might catch the logical error.
Because they're analyzing the words.
Exactly. But if Claude renders a flawless interactive bar chart right in the chat interface, complete with tooltips and a legend, the executive brain just accepts the trend line as absolute truth.
It looks finished, it looks authoritative, so we assume the underlying math is flawless.
Yeah, you're removing the human in the loop from the data translation layer,
The model is making unilateral decisions about how to scale the y-axis.
which is huge.
It decides which outliers to exclude to make the chart look cleaner and what color scheme implies positive or negative momentum. These are highly subjective analytical decisions being masked as objective graphical outputs.
And taking action on that data brings us out of the chat interface and directly into the browser, which is where the mechanical reality of these tools gets incredibly messy.
Oh, very messy.
Let's look at the integration of Chrome alongside the Cowork application.
So Claude in Chrome is currently in beta for paid plans.
Right.
The intended functionality is that it acts as a research layer that can actively navigate websites, read DOM elements, and extract structured data for you.
So it's scraping the web for you.
Essentially, yes. You are meant to pair it with Cowork, where the Chrome extension gathers the unstructured web data, and the Cowork desktop application synthesizes that data to generate finished local files.
Like complex Excel models or formatted PowerPoint decks.
Exactly.
Now, on paper, that sounds like the ultimate workflow, but practitioners are finding a severe underlying conflict.
Yeah, it breaks.
Running the Claude Desktop's Cowork feature silently breaks the Chrome integration and vice versa.
They are actively competing for the same operating system resources.
Specifically, they use conflicting native host binaries. Now, walk me through the mechanics of that, because it sounds like a massive oversight. What exactly is a native host binary, and why are they fighting?
Well, to understand the failure, you have to understand how browsers isolate code.
Okay.
A web browser extension operates in a highly restricted sandbox. It cannot directly read or write files to your local hard drive for obvious security reasons.
Right, we don't want random websites downloading stuff invisibly.
Exactly. To bridge that gap, Chromium-based browsers use a protocol called native messaging. This requires a specific JSON manifest file, a native messaging host, that explicitly tells the browser it is safe to pass messages to this specific local application using standard input and output streams.
So it's essentially a pre-approved communication bridge through the browser's security wall.
Precisely. Or rather, that is the intention.
But something went wrong.
Both the Chrome extension and the Cowork desktop app are hard-coded to register and utilize the exact same identifier.
Wait, really?
Yes, they both use the com.anthropic.claude.json native host binary. They're both trying to claim ownership of that specific communication pipeline.
Oh, wow.
When both applications are active, the operating system's inter-process communication, or IPC, fractures. The system just doesn't know which application should receive the message payload.
So the communication bridge collapses and the browser extension silently fails. And the fix for this, I read this online, the fix requires an end user to dig into their hidden system directories, manually rename the JSON files, and force a full browser restart.
Which is ridiculous.
It is. This is the duct tape reality of enterprise AI right now. We have vendors selling a seamless, autonomous future to the C-suite, but the actual practitioners on the ground are busy renaming hidden configuration files just to stop their web browser from crashing during a demo.
It is beta software masquerading as finished enterprise infrastructure.
Completely.
But, while the browser integration is clearly suffering from resource collisions, the command line interface is rapidly acquiring alarming levels of autonomy that bypass the browser entirely.
Yeah, let's talk about the terminal.
We need to examine the new /loop command introduced in Claude Code.
This is where we cross a threshold. Claude Code now features a built-in /loop scheduling command.
Yes.
You can set it to run on a recurring interval for up to 3 days from a single terminal session.
3 days.
You do not need to write external cron jobs. You don't need to build Python wrapper tooling. A developer can literally type /loop 1 hour, check the deploy logs, and summarize new errors into their terminal, and the agent just executes it.
Every single hour.
For 3 days.
This represents a fundamental architectural shift in human-computer interaction. We have spent the last 50 years in a reactive compute paradigm. The computer waits for your explicit input, processes it, and returns an output.
Action-reaction.
Right. The /loop command moves us into proactive, scheduled agentic behavior. The system is no longer waiting for a prompt. It is initiating complex actions based on an internal clock, utilizing the full suite of file editing and network tools enabled in its environment.
I want the listener to really visualize this scenario. Imagine leaving a highly eager but incredibly literal-minded intern completely alone in your server room for a 3-day holiday weekend.
It's terrifying.
They don't need to sleep. They just sit there checking the production logs every single hour. What happens when that agent misinterprets a benign warning log on hour 48?
Oh, things go bad fast.
Does it attempt to write a patch? Does it initiate a rollback? Does it start opening dozens of unnecessary JIRA tickets and paging the on-call engineer at 3 a.m. because it hallucinated a critical failure based on a misinterpreted memory state?
You are describing the precise mechanics of compounding context degradation.
Compounding context degradation. Okay, explain that.
When an agent loops, it is carrying forward the context of its previous actions. If it makes a very slight logical error on loop number 4, perhaps it misidentifies a variable state and then bases the logic of loop number 5 on that flawed assumption, the error compounds.
It snowballs.
Exactly. By loop 48, the agent could be wildly off track, taking autonomous, potentially destructive actions based on a completely hallucinated internal state of the system architecture.
And what about the infrastructure costs? If you tell it to monitor the database for anomalies, and it decides the best way to do that is to run complex, unoptimized GraphQL queries against your production database every 5 minutes,
Yeah, good luck.
you could rack up a massive AWS compute bill over a weekend before a human ever realizes what the agent is doing.
The resource consumption is entirely unconstrained. But the truly concerning element is how the agent communicates with the developer when it inevitably encounters one of these degraded states.
Right.
It now has a way to bypass internal communication channels entirely.
Which brings us to channels. Launched on March 20th, 2026, Claude Code Channels allows users to connect their terminal agent directly to Telegram or Discord.
Yeah, and the implementation is remarkably straightforward, which is exactly why it is problematic from an administration standpoint.
Too easy to set up.
Yes, a developer configures a simple bot on Telegram, links it via the /telegram:configure command in their terminal, and pairs it with a temporary security code.
And then what?
Suddenly, you can issue root-level terminal commands to your local machine from your mobile phone while you are sitting in a coffee shop away from your desk.
So it acts as a remote field radio for your autonomous agent.
Exactly.
I cannot overstate the security nightmare this creates. Think about standard enterprise security posture. We spend millions on mobile device management, VPNs, and Okta authentications to ensure that only approved devices can touch the code base.
Right, perimeter defense.
But by using this Telegram integration, you have just opened a direct pipeline from a consumer-grade messaging app on an employee's personal unmanaged iPhone straight into the corporate development environment.
The traditional network perimeter defenses are completely blind to this.
Wait, let me expand on that. If an employee's personal Telegram account is compromised through a basic SIM swap attack or a targeted phishing link, the attacker doesn't just get access to their private group chats.
No, they get the keys to the kingdom.
They instantly get a command line interface directly into your proprietary codebase.
Yeah.
And it's powered by an AI agent that is eagerly waiting to execute any command the attacker types in. Please zip the entire repository and send it to this external IP.
And the agent will happily oblige.
It will.
And your enterprise firewall will not flag it as an intrusion.
Because it looks like normal traffic.
Why? Because the network traffic is originating from a locally authenticated Claude Code session that the employee legitimately authorized on their managed corporate machine.
Wow.
The firewall sees an outbound API call to Anthropic servers, which is approved traffic, not an inbound malicious command from a Russian IP address via Telegram. It is an entirely new, sophisticated attack vector that traditional endpoint detection and response tools are currently unequipped to monitor.
It is terrifying. We are building these massive backdoors simply because developers don't want to open their laptops on the weekend.
Pretty much.
But even when developers are actually sitting at their desks during working hours, the fundamentals of how they interact with the machine are changing. They aren't even typing anymore.
Right.
That is where voice mode comes in.
Voice mode is currently rolling out to roughly 5% of the user base. It operates as a push-to-talk system within the interface. You type /voice, hold down the spacebar, articulate your command, and release. From a technical and acoustic standpoint, the speech-to-text models have been heavily fine-tuned specifically to recognize obscure technical terms.
So it understands jargon.
Right, proprietary repository names and complex programming syntax with a high degree of accuracy.
Now, dictating code sounds incredibly futuristic. It sounds like something out of a sci-fi movie. But I have a very serious pushback on the reality of this workflow.
Oh, I agree with you.
Typing slows you down, and that is a feature, not a bug. The physical friction of a keyboard forces a developer to actively think about the logic, the architecture, the variable names, and the edge cases before they hit enter and commit the prompt.
Yeah.
When you remove that friction, you remove the deliberation. Without a keyboard slowing you down to think, voice mode might just be the most efficient mechanism ever invented to generate incredibly bad code significantly faster.
There is a deep truth to the psychological difference between typing and speaking. When human beings speak, our natural language is inherently conversational, implicit, and highly imprecise.
We just ramble.
We do. A developer holding down the space bar is highly likely to say, "Hey, Claude, build me a quick login screen with a standard database backend."
Which is awful.
That is an objectively terrible engineering prompt. It lacks specifications, constraints, and security requirements. But the AI will enthusiastically accept it and attempt to fulfill it.
And in doing so, the AI has to fill in the blanks. It will start making massive unilateral assumptions about password hashing protocols, database schemas, and session state management that the developer never actively considered, simply because they were talking too fast.
Which perfectly illustrates why the next feature they released is so critical, yet fundamentally flawed.
Yeah, how do we catch that bad code?
How do we catch that rapidly generated, assumption-riddled code before it hits production? Anthropic's answer is Claude Code Security.
This is currently in a research preview phase for team and enterprise plans. It actively scans your entire code base for vulnerabilities and automatically suggests patches.
Right.
Anthropic is very careful to insist in their documentation that absolutely nothing is committed to the repository without explicit human sign-off. But I look at this and see a massive, glaring conflict of interest.
This raises an important question. We are creating a closed-loop system where the exact same underlying AI model that generates the code in the first place is now being tasked with reviewing that same code for security flaws.
It's grading its own homework.
Exactly.
The failure mode here isn't malicious. It's not that the AI is going to actively write a bad patch to sabotage the company. The real insidious danger is human alert fatigue and automation bias.
Oh, automation bias is a huge problem here.
Think about the workflow. The AI writes the code. Then the AI security module reviews its own code and presents a summary to the developer saying, "I reviewed this, it looks perfectly secure, please approve." We are actively training human engineers to blindly click approve because the AI system usually gets it right.
The psychology of automation bias is well documented in aviation and medicine. When a highly sophisticated, historically reliable automated system tells a human operator that everything is fine, the human operator naturally drops their guard.
They just trust the machine.
Right. In software development, if the AI hallucinates a secure memory boundary that doesn't actually exist in the compiled code, the human reviewer who didn't even write the code themselves and is likely just scanning a summarized diff on their screen will almost certainly greenlight that critical vulnerability straight into the production environment.
We are entirely losing the adversarial friction that makes code review actually work. A human peer reviewer asks hard questions because they didn't write it.
I want to find mistakes.
Yeah. An AI reviewing its own output lacks that adversarial distance. And this culture of blind trust in autonomous execution is rapidly expanding beyond the engineering department and bleeding into the broader knowledge workforce.
It really is.
Let's examine Cowork Desktop and the reality of the VM Sandbox.
Cowork on desktop, specifically for Max Plan subscribers, brings this agentic, autonomous task management out of the developer terminal and into the hands of everyday knowledge workers.
So financial analysts, HR managers, marketing teams.
Yes. The critical architectural detail we must examine here is how it is deployed. It runs locally on the user's machine inside an isolated virtual machine, a VM, but it demands direct file access to function.
Okay.
This signals the official transition toward the AI becoming the primary operating system interface for your entire workflow, intending to bypass traditional software application windows entirely.
I have to ask you, the listener, to really think critically about this. The vendors assure us this is safe because it's in a sandbox.
Right. Quotes around Sandbox.
But if an AI requires direct, unmediated file access to your local machine to read your spreadsheets and summarize your PDFs, does an isolated VM actually protect corporate data, or does it just create an incredibly dangerous false sense of security for the IT compliance team?
In the context of data exfiltration, it is largely a false sense of security. We need to distinguish between hardware protection and data protection.
Okay, break that down.
A virtual machine sandbox is designed to protect the host operating system from malicious code execution. It prevents the AI from accidentally deleting your System32 folder or corrupting your boot drive.
So it protects the physical machine.
Right. It does absolutely nothing to protect the actual data payload that you have explicitly granted the AI permission to access and manipulate.
So if the AI has direct file access to my local Q3 strategy documents folder so it can build a PowerPoint presentation, the sandbox does not prevent the AI from accidentally emailing those highly confidential reports to the wrong client.
Not at all.
Or worse, if the AI is subjected to a prompt injection attack from a malicious website it was asked to research for background data, the sandbox doesn't stop it from exfiltrating that local data to a third-party server.
Exactly. The sandbox protects the hardware infrastructure. It does not protect the logical workflow or the data integrity. And while enterprise security architects are spending months locked in meeting rooms debating the theoretical security of these VM sandboxes, the open source community is completely ignoring the debate.
They're just moving on.
They are just sprinting ahead, building massive, complex infrastructures on top of these very systems at breakneck speed.
The scale of the community adoption is just staggering. These open source repositories are reshaping the landscape significantly faster than the official vendor releases. Let's look at a community repository called Superpowers.
Oh, Superpowers is huge.
It has already passed 90,000 GIT Hub stars. It isn't just a simple script. It provides a highly structured 7-phase development workflow. It forces the local agent through a rigorous process of Socratic brainstorming, then moves it into sub-agent test-driven development, and finishes with a systematic code review before presenting anything to the user.
It is essentially codifying senior engineering management practices into an automated agent workflow.
Yeah.
And alongside Superpowers, you have frameworks like Dispatch. Dispatch is designed to fan complex tasks out to multiple background worker agents, each operating with fresh, clean context windows.
I want to dig into Dispatch because the way it handles context degradation is fascinating. How does it prevent the compounding errors we talked about earlier with the /loop command?
Dispatch approaches the problem by parallelizing the agents rather than infinitely looping a single agent.
Okay.
If a subordinate worker agent gets stuck on a logic problem or encounters an error it cannot resolve, Dispatch pauses that specific worker. It surfaces the specific blocker back to the human user as a targeted question.
So it just asks for help instead of guessing.
Yes. The human user answers the specific question, and the agent resumes its task. It achieves this without having to restart the entire session or lose the accumulated context of the parallel workers.
That's incredibly smart.
It dynamically manages the context window across multiple isolated agent states. And then you have repositories like Awesome Agent Skills, which is essentially a massive crowdsourced catalog of pre-built tools allowing your local agent to interact directly with infrastructure platforms like Stripe, Cloudflare, and Netlify.
Here's where it gets really interesting. A month ago, to use any of this, you had to be a developer. You had to clone the repository from GIT Hub, manage the dependencies, run complex Python setup scripts.
Right, there was friction.
You don't have to do that anymore. These advanced workflows are sitting right now in the official Anthropic plugin marketplace.
A non-technical user can simply open their terminal, type /plugin install, and the local isolated agent suddenly inherits the collective workflow wisdom of 90,000 open source developers.
In seconds.
It instantly gains the ability to securely authenticate and directly manipulate your corporate Cloudflare DNS settings or your Stripe payment gateways. Contrast the sheer velocity of these community deployments with traditional corporate software procurement.
It's night and day.
In a standard enterprise, it takes 6 months, 3 security audits, and legal review to approve a new vendor for a basic project management tool. Meanwhile, the open source community is deploying fundamental architectural shifts to how software is written and deployed overnight, and employees are installing them with a single command.
Which perfectly synthesizes the reality we are facing. Think about the timeline we have just meticulously walked through. Anthropic shipped 9 major paradigm-shifting features in a mere 7 days.
Right.
The open source community shipped complex orchestration frameworks that instantly gathered 100,000 stars and massive adoption. The plugin marketplace is entirely flooded with powerful tools built by individual developers whose own corporate security teams have likely approved them for their own internal use.
If we synthesize this macro trend, the conclusion is stark and unavoidable. The gap between what is currently available on the ground to your employees and what your IT department has actually vetted, audited, and approved is no longer narrowing.
No, not at all.
It is a permanent reality. IT procurement and security review cycles are fundamentally measured in fiscal quarters. AI capability deployment cycles are measured in days.
We have to redefine what shadow IT actually means. 5 years ago, shadow IT meant an employee expensing a personal Dropbox account because the corporate SharePoint server was too slow.
Right.
We understood that risk. It was static data storage. Today, shadow IT is an autonomous, persistent agent silently reading your company's live production deploy logs, executing undocumented code to fix perceived errors, and sending status updates to a developer's personal Telegram account on an unmanaged device.
All authorized by an employee who simply wanted to save a few hours of manual work over the weekend.
Exactly.
The traditional methods of auditing this exposure are obsolete. You cannot rely on standard network traffic logs to catch this. To the firewall, the traffic is heavily encrypted and looks exactly like standard, approved API calls to Anthropic's endpoints.
It's totally opaque.
The firewall cannot differentiate between a user asking for a recipe and an autonomous agent rewriting your database schema.
So how do you actually audit your own exposure right now? We have a practical, immediate governance check you can run the moment this deep dive ends.
Yeah, everyone should do this.
Open Claude on your work machine, start a brand new, empty conversation, and simply ask it, what do you remember about me?
Read the resulting output very carefully. Analyze the specific details it brings back from the ether. If the system recalls significantly more than you explicitly expected, if it casually lists your internal project code names, your specific coding habits, the exact nomenclature of your company's proprietary backend databases, or the nuanced details of your unreleased Q4 product strategy, you inherently have a severe governance problem.
Because if it remembers those details, it is actively using them as foundational context for all future outputs. That highly sensitive corporate data has fundamentally left the ephemeral, isolated chat window. It has become a permanent part of the persistent state of a third-party applications architecture. This is the only test that matters before you start relying on the system for critical enterprise workflows. If you do not definitively know what the system is remembering, you do not control your corporate data. Period.
Building on the reality of this permanent, unbridgeable IT gap, here is a final architectural thought to mull over. We have established that these local agentic Cowork instances are incredibly powerful and increasingly autonomous.
Right.
What happens next month when your local agent begins natively communicating with a vendor's autonomous agent across company lines?
Oh, wow.
If your automated procurement agent starts talking directly to a software vendor sales agent to negotiate a contract renewal or share performance telemetry data via an API, where does the enterprise firewall exist then? We are spending millions securing the network perimeter, but the agents are already authorized to talk right through it.
That is why ClaudeHQ.app exists, free, no account. Models in plain language. Prompts that work. Send it to anyone who closed the tab frustrated. Everything is at AIFrankly.com. Subscribe on Substack, watch on YouTube, listen on Apple Podcasts and Spotify. Just search AI Frankly, AI Frankly, the memo your IT team didn't get.